Hello everyone, welcome back again to Excellent Solutions, a guide to score 300 plus in JAM. Today we are going to be discussing physics and the topic is progressive wave equation. We have these questions under progressive wave equation, but before we start solving the question, let us have an introduction of the progressive wave equation. So a progressive wave equation is an equation that is given by y is equal to a sine omega t plus or minus pi, where this a is the amplitude, omega is the angular velocity, and pi is the phase angle. So this omega for here, where we have omega is equal to 2 pi f o is equal to 2 pi. This f frequency of a wave is given by v upon lambda, and the phase angle pi, the phase angle pi is equal to kx, and our k, the wave number, is equal to 2 pi upon lambda. So if this k is equal to 2 pi upon lambda, we can imply that this lambda, when we make it the subject, we will have lambda is equal to 2 pi upon k. So with these equations, we are going to use them to develop our wave equations. So therefore, we now have y is equal to a sine, we can now have omega t, then plus or minus this pi, we say is equal to kx. So this we now have kx. So and with this kx, we can now, if we substitute the value of k as 2 pi upon lambda, and this omega is equal to 2 pi f, we are now going to have y equal to a sine 2 pi f t. This 2 pi f comes for this omega, where we say omega is equal to 2 pi f here, and plus or minus this k, we said is 2 pi then upon lambda, and we have this x. So y is equal to 2 pi ft plus or minus 2 pi x upon lambda. And also we can now say this y is also equal to a sine, then we now have 2 pi f, if we use this value for omega, 2 pi v upon lambda, then t plus or minus 2 pi x upon lambda. So with this one, we can now factor 2 pi f upon lambda, 2 pi f upon lambda out. So we now have y equal to a sine, then we have 2 pi upon lambda out, then open into we have vt plus or minus x. So we can use these equations for solving our progressive wave equation. So let me transfer these equations that we may be needing to solve our progressive wave equation. That since omega is equal to 2 pi f, we can now say our f is equal to omega upon 2 pi. And we have our lambda, so we now clean this one and write for the ones we needed. F equals to 2 omega upon 2 pi, and lambda equals to 2 pi upon k. Also, we have another important equation, v equals to r lambda. So we are going to use these equations, very important in solving our problems. So to solve this our problem, the first question that we have here says the equation of transverse waves traveling along a stream is given by y equal to 0.3 sine 0.5x minus 50t. So this is an equation that is moving from left to right. So in this case, we are going to compare this equation with, we have the first equation 1, we have y equal to 0.3 sine 0.5x minus 50t. So this equation, the first thing we need to do, we compare this equation with y equal to a sine kx minus omega t. So if we look at this two equations. We have sine here, we have sine. The coefficient of sine here is 0.3. The coefficient of sine here is A. So A is the same as 0.3, and the amplitude, the question says where x and y are in centimeters and t is in seconds. Find the maximum displacement of the particle from its equilibrium position. So the maximum displacement of the particle from its equilibrium position is the amplitude, which is the same as A. So therefore A is equal to 0.3 meters. And if we look into the options, option D says 0.3 centimeters, and that is the answer. So, but since we are now starting solving questions under progressive wave equation, let's use this equation to solve for other values so that we can understand the concept better. So if you look at this, the coefficient of x here is k, the coefficient of x here is 0.3. So we can now say k equals to 0, okay, so 0.5, so 0.5. The coefficient of t here is omega, the coefficient of t here is 50. So we can now say our omega equal to 50. So in this case, if we are asked to find the angular velocity, it's just equals to 50 rad per second. And for us to get the frequency, we say the frequency f is equal to omega upon 2 pi. So we now have f equals to omega upon 2 pi, which is the same as 50 upon 2 pi, 2 here, 1, 2 here, 25, and this gives us 25 upon pi hertz. And if we are looking for the wavelength, we have lambda here, lambda equals to 2 pi upon k, and this now becomes 2 pi upon, our k is 0.5, so we have 2 pi upon 0.5, and this is the same as 4 pi. So this is now finding the frequency and the wavelength. And if the question asks us to find the velocity, we have v equals to 2 f lambda. So if v equals to f lambda, we have our f here as 25 upon pi, 25 upon pi times our lambda, which is 4 pi, and this now becomes pi cancel pi, we have 4 times 25, we now have equals to 100 meters per second. So this is in a situation where we need to find the wavelength, frequency, and the velocity of the wave. So, but for the case of this question, the answer is just A is equal to 0.3, and that is the answer for that. The next question is question 2. And question 2 says the equation of wave traveling along the positive x direction is given by y is equal to 0.25 times exponential 3. So question 2, y equals to 0.25 exponential minus 3 sine, we have 500t minus 0.25 x. So determine the angular velocity of the wave. Determine the angular velocity. We just compared it with y equals to a sine omega t minus kx. And in this case, coefficient of t is omega, coefficient of t is 500. So omega equals to 500 rad per second. So we look at the option. Option A, we have 0.25 exponential 3 exponential minus 3 rad per second. B 0.25 exponential minus 1 rad per second. C 5.00 exponential 2 rad per second. Since the answer is in exponential, we can make this one to be equal to 5.00 times 10 raised power of, we take this point 1, 2. So times 10 raised power of 2 rad per second. And we answer this question. So the answer here is C. So if we look carefully to understand more on the progressive wave equation, our amplitude A is the same as 0.25 exponential minus 3. And our K here is equal to 0.25. And the angular velocity is equal to 500. So we are looking for the frequency here. We say F equals to omega upon 2 pi, which is the same as 500 divided by 2 pi. 500 divided by 2 pi, 2 here 1 and 2 here we have 25. So this now becomes 250 upon pi. Okay, 250 upon pi, and this is the angular frequency. Wavelength, lambda equals to 2 pi upon k, and this now becomes 2 pi upon, our k is 0.25, this is 0.25, and remember 0.25 is the same as 1 over 4, so this is the same as 2 pi over 1 over 4. This now becomes 4 will go up, this becomes 8 pi. So this one becomes 8 pi. Our velocity v equals to f lambda, so this now becomes 250 upon pi times the lambda wavelength, units in meter, units is in hertz, so we now have times 8 pi. Pi cancel pi, 250 times 8, we have 2000. So this now becomes 2000 meters per second. This is if we are to look for the frequency, wavelength and wave velocity for the case of this question. But for the answer to this question is just omega is equals to 500, which is the same as 5 exponential 2 rad per second. The next question is question 3. And question 3 says, given the progressive wave equation, y is equal to 5 sine 200 pi t minus 0.4 x. Calculate the wavelength of the wave. So this one is also very simple. We know that our k is 0.4. So our wavelength, we have lambda equals to 2 pi upon k. And our k is equal to 0.4. Let's say k equals to 0.4. So this now becomes 2 pi upon 0.4. So, and you know 0.4 is the same as 2 upon 5. So this now becomes 2 pi upon 2 upon 5. So this now becomes lambda equals to 2 pi upon 1 times 5 upon 2. 2 cancel 2 and is equals to 5 pi. So 5 pi lambda will now be 5 times 3.142, and this is the same as 15.7 meters. So our lambda is 15.7 meters. If we look at the option A 12.4 meters, option B 15.7 meters, so option B is the answer. So that is for the case of this. And if you are asked to find, that's we solve this question, but that is answer is B. But if you are asked to find the velocity, up to the velocity, so in this case for this wave, amplitude is 5, the angular velocity omega is equal to 200 pi. So if we are looking for the frequency, f equals to omega upon 2 pi. So this now leaves us with 200 pi upon 2 pi, and this now becomes 100. So if this one becomes 100, okay, 100 hertz, and the velocity v equals f lambda. So this now becomes 100 times 15.7, and this is same as 1570 meters per second. So this is in terms of the velocity of this question. Question 4 says, the equation of wave traveling along the horizontal direction is expressed as y is equal to 15 sine. Y equal to 15 sine, we have 2 upon 5 into 60t minus x. Okay, so what is the wavelength? So the question here asks us what is the wavelength. So this equation, we are going to compare it with this equation. So compare with y equals to a sine 2 pi upon lambda into dt plus or minus x. So if you compare, the amplitude is 15. This 2 pi upon lambda is the same as 2 upon 5. So this now we can now say 2 pi upon lambda is equals to 2 upon 5. So this is in the case of this question. So in this case, if we now make our comparison, we now have 2 cancel 2. We cross multiply, we are going to have lambda equals to 5 pi. And 5 pi is the same as 5 times 3.142, which gives us 15.7 meters. So if we look at our option, option A 60 meters, option B 15 meters, C 5 meters, D 2 meters. So since we have 15 meters, we take it to the whole number, which is 15 meters, and the answer here is option B. And also, if we are to look for the velocity, V is the same as 60. So for this one, the velocity is given. We have the velocity as 60 meters. The next question here is question 5. And question 5 says, the equation of wave is y equal to 0.005 sine, we have 0.5 x minus 200 t, where x and y are in meters and t is in seconds. What is the velocity of the wave? So since this one asks us to find the velocity, remember we have been looking for velocity. I used to get up to the point of finding the velocity to understand the concept of the progressive wave better. So here we just compared with y equal a sine kx minus omega t. So looking at this comparison, amplitude is 0.05, k is 0.5, and omega is 200. So we can now start with this. We can now say frequency F equals to omega upon 2 pi. And this omega is the same as 200. So this now becomes 200 upon 2 pi. 2 here, 1, 2 here, we have 1. So this now becomes 100 upon pi hertz. That is the frequency. And the wavelength, lambda is equal to 2 pi upon k. And looking at this, our k is 0.5. This is now 2 pi upon 0.5. And this is the same as, anything divided by 0.5 is double of that. So this is the same as 4 pi meters. And the velocity, v, is equal to f lambda. So this now becomes, our f is 100 upon pi, times the wavelength, lambda is equal to 4 pi, pi cancel pi, and this now becomes 100 times 4, which is 400 meters per second. So if you understand this concept as we are solving, the progressive wave equation will become easier to solve for you. So the next question is question 6. So question 6 says, the equation of wave, a progressive wave is represented by y equal to 10 sine 1000 t, y equal to 10 sine 1000 t. Let me clean this since we are done with trying to find what they are. Okay, 1000 t minus pi x upon 34. So sorry to clean these equations. So the two layers of the wave are separated by 153 centimeters, and we have x is equals to 153 centimeters. Okay. Have a pace difference of, so this one we are asked to find the pace difference, pi, where we know that pi is equal to 2 pi x upon lambda. So if you now want, the first thing that we need to do is compare this equation with our other equations that we have. Y equal to 10 sine 1000t minus pi x upon 34. We compare it with y equals to a sine omega t minus k x, okay, minus 2 pi x upon lambda, or we compare it with that other equation that we cleaned, 2 pi v t upon lambda minus 2 pi x upon lambda. Remember, we cleaned that equation there. So if we compare here, amplitude is 10, 1000 is the same as 2 pi v upon lambda, and pi x upon lambda is the same as 2 pi. Okay, pi x upon lambda is the same as 2 pi x upon lambda. But one thing that we need to find is the value of lambda, which is what we don't know. So we now take this and compare. We now have this pi, this one, pi upon 34, or let's just take them. Pi x upon 34 is equal to 2 pi x upon lambda. Okay, so now from this one, pi cancel pi, x cancel x. We now have, when we cross multiply, we now have lambda equals to 2 times 34, we now have 68. So if we have this, lambda equals to 68 meters. So if lambda is equal to 68 meters, I will clean these ones since we have gotten the value of lambda. We now come here and say our phase angle is equal to 2 pi x upon lambda, which is now the same as, so let me put this. And since we get lambda equals to 68, so this now becomes 2 times, since the question asks us to find phase angle, here we are looking for angle, not the wavelength. So we are going to use the value of pi as 180 degree, pi in degree. So this now becomes 2 times 180 times x is given as 153, 153 divided by 68, the value of lambda. So if you now look here carefully, look what I'm going to do here. 2 here is 1, 2 here we have 34. So if we have this as 34, 2 into 180 we have 90, 2 into 34 we have 17. So 17 here 1, 17 into 153 we have 9. So 9 times 90 is just the same as saying 9 times 9 you have 18 and you put 0, or 9 times 90 is equal to 810 degree. So this 810 degree, if you replace the value, is the same as saying sine 900 minus sine 900 minus 810, and is the same as 90 degree. Or if you press the value of sine 810 is the same as sine 90. So this is equivalent to 90 degree. So the answer, if we look at the option A 270 degrees, option B 40 degrees, option C 90 degrees. So the answer here is C, 90 degrees. 90 degrees. The next question is question 7, and question 7 says a traveling wave moving from left to right has an amplitude of 0.15 meters. So we now have A equal to 0.15 meters. Okay, a frequency of 550 hertz. F equals to 550 hertz, and a wavelength of 0.01 meters. Lambda equals to 0.01 meters. The equation describing the wave is, so this one, all we have been doing before is getting the values of the parameters, but here we have been giving parameters to form an equation. So what we need to do here is that we start comparing the equation. Y we said equals to A sine, we have kx minus omega t. Or we can say, okay, let's say kx minus omega t. So, or we can just put it as this: a sine 2 pi x upon lambda minus 2 pi ft. If we compare these equations with what we are having here, so our a, we can now say y equals a is amplitude, which is 0.15. Then sine, we have 2 pi is common. Then we have x upon the lambda is 0.01 minus, here we have 2 pi times the frequency 550, then t. So we now come here, we can now see y equals, okay, look at what we do here: 0.15 sine, when you divide 2 by 0.01, you are going to have 200. So we now have 200 pi x, then minus this one, let's say we have 2 pi, this 550, we can make it as, let's say, 5.5 times 100 is the same as 550. So this 550, we can write it as 100 times 1.5. So let's say times 100 times 5.5 t. So if we multiply 2 pi times 100, we are going to have 200. So this now becomes y equals 0.15 sine 200 pi x minus 2 pi times 100, we have 200 pi times 5.5 t. So if you look here, we can factor this 200 pi out. So we are having y equals to 0.15 sine, we now see 200 pi out into x. So 200, okay, 200 times 200 pi times x, we have 200 pi x minus this one, we factor it out, then we have 5.5 t. And if you look into the option A, y equals 0.15 sine 200 pi open bracket x minus 5.5 t, and option A satisfies our equation. So if you are watching these these questions are brought to you from this book, which is the Excellent Solutions, a guide to score 300 plus in JAMB. This is for the physics. So you can look for this book and start reading for your JAMB. With this book, you have a sure guide to pass your JAMB, since it can provide you with good training for you. So kindly subscribe to this channel so that you will be notified whenever I post a new video. Thank you very much.